Right, we need to consider the quadratic pattern with the terms 2, k, 20, 35, and so on. And we shall proceed to calculate the value of k in B, hence determine Tn, the general term of the sequence. We proceed to solve this problem in a step-by-step manner as follows. Right, so first things first, we write down the sequence in part A. And we start with 2, k, 20, 35, and so on. So here we have k minus 2, 20 minus k, and we have 35 minus 20, which is 15. Next, this term minus that term actually give 22 minus 2k. Then this minus that give us exactly k minus 5. Okay, because this is a quadratic sequence, what we then have is therefore that this term must be equal to this. So in other words, 22 minus 2k must be k minus 5, which means therefore what we have here is that 22 minus 2k is equal to k minus 5. So that when we have 3k, it is exactly the same as 27. Dividing both left and right by 3, we have that k equals 9. Hence k equals 9. So we've answered the first question because the first question was that consider the quadratic pattern this, and we're to calculate the value of k. We needed the numerical value of k, and we have just found that is k equals 9. Then we have the second part of the question B. And the second part of the question B is hence determine Tn, the general term of the sequence. So if you have that k equals 9, and we have the sequence 2, k, 20, and 35. So we have the following, part B. So we're going to have exactly 2, 9, 20, 35, and so on. So that in the end now, if you subtract these, and you're going to have 9 minus 2, which is exactly 7, 20 minus 9, which is 11, and then we have 35 minus 20, which is 15, and we get further differences here. Right, 11 minus 7 gives us a 4, and 15 minus 11 gives a 4. 2a equals 4. 3a plus b equals this. A plus b plus c equals 2. And if this is the case, right, we then say 2a equals 4. That is part B. Dividing by 2 means a equals 2. Also, we have 3a plus b equals 7. 3a plus b equals 7, so that we have 3 into 2 plus b equals 7, which means 6 plus b equals 7, which means b equals 7 minus 6, which is 1. We have a plus b plus c equals the first term of the quadratic. So a plus b plus c equals 2. A equals 2 and B equals 1. A equals 2 and B equals 1 plus C equals 2. So which means C equals minus 1. T sub n is an squared plus bn plus c. Okay, plus bn plus c. Which means T sub n equals A. And A is exactly the same as 2n squared. B is 1. C is minus 1. So this is the quadratic, this is the general term of the quadratic sequence, the quadratic pattern. Okay, the general term is 2n squared plus n minus 1. Okay, now we can do a check. The examiner did not ask us to check, but we can do a check in part B. How do you do a check? Okay, we got that Tn equals exactly 2n squared plus n minus 1, so that T1 is T into that squared plus 1 minus 1, which equals 2. T2 in this case equals K. Remember that T2 equals K, and we remember that K is 9. So obviously, we recall, therefore, that we had the sequence A up to K, 20, and 35. So, but we got K equals 9. So let us just verify if this is the case. So this is 2 into 2 squared plus 2 minus 1, which is 2 squared. 4 by 2, 8, plus 2, 10, minus 1, which is exactly a 9. So obviously just produce the K equals 9 here, so we are done. Right, so we've solved this quadratic number pattern problem in detail, and we're done. Thanks everybody for your attention, and goodbye to you.